Log scaling hasn't really changed that much in the last decade. The techniques are still basically the same. You measure the length and the ends of the log to determine the volume, deduct for any defects, and record the information in your tally sheet. The only major change has been the change to the metric system. This means you will have to learn a new system of measurement. You will have to learn to use and understand the metric terms of measure. Instead of log length being measured in feet and recorded to the nearest foot, it will now be measured in meters and recorded to the nearest 0.2 meters. Volumes and deductions will now be calculated in cubic decimeters instead of cubic feet. And who will be affected the most by this change? The grader? The bucker? The weigh scale attendant will have to change, but it won't be much of a change. He will now record the weight of the logs in kilograms instead of pounds. It's you, the log scaler, who's going to be most affected by this change to metric. It's not really that much of a change, but let's look at how it will affect you. Not in theory, but out there on the logs where it really counts.
Metric system. They want me to learn the metric system. As if I didn't already have enough to think about. Now I've got to learn to think in meters. Meters. I wonder how many meters that log is. Or how many meters that logging truck over there is. It'll probably just slow me down anyhow.
It probably will slow you down at first, but once you've mastered the metric system, you will be using meters and centimeters without even thinking about it. 10 is a much easier number to multiply or divide by than 12. You just move the decimal point, and that's just one of the advantages of the metric system. Most of the world now uses the metric system as the accepted standard, and those not using it will soon be changing. Even the United States, our major timber buyer, is changing to the metric system. British Columbia does a lot of trading to the world markets from its harbors. Given a little help, BC could become a leader in the move to metric. Each year, British Columbia produces millions of cubic meters of lumber for markets at home and abroad. In order that the forests may be properly managed, the quantities of timber removed must be measured and recorded. Stumpage will be calculated according to the figures that you, the scaler, enter in your tally sheet. You will determine how many millions of cubic meters we process in British Columbia. You've been asked to show the lead in accepting the change to metric. There are 3 areas where the change to metric will affect you most. The new metric rule, the calculation of deductions, and on the log boom, the length of pace. Your new metric rule has the same basic functions as the old one, but the numbers and their relationships have changed. Once you understand the relationships between these numbers, you will be well on your way in making the change to metric. Instead of measuring in inches across the diameter of the log, the new stick is now marked in 2-centimeter units. This effectively gives you the radius of the log with the same measurement technique. The black numbers on the edge of the stick identify the radius class. All measurements that fall between 2 of these marks will be recorded as the whole number. Red numbers are inscribed at 0.2 meter intervals from the inside edge of the tine. When measuring log lengths, any measure falling between 2 red lines will be recorded as the red number. These marks will aid you in measuring lengths to the nearest 0.2 meters. On the side of the stick are numbers in black for each radius class. They represent the half volumes in cubic decimeters for cylinders of various lengths, from 3 to 7 meters on one side of the stick, and from 8 to 12 meters on the other side of the stick. At right angles to these numbers is the half volume of a 2-meter cylinder. This also corresponds to the full volume of a cylinder of that radius class, 1 meter in length. Here's an example. You have a log 11 meters in length with a top radius of 40 centimeters and a butt radius of 50 centimeters. Using your stick, look up the half volume for a cylinder 11 meters long under the 40 centimeter class, which is 2765, and the half volume for a cylinder 11 meters long under the 50 centimeter class, which is 4320, and add them together. This will give you the volume of the log in cubic decimeters. This brings up a point that needs to be talked more about. The use of the decimal in the metric system is one of the most valuable tools you have. Take a log 11.6 meters long with a top radius of 40 centimeters and a bottom radius of 50 centimeters. This log you must compute as the half volume of an 11-meter log and the half volume of a 0.6 meter log. Since there is no 0.6 meter measure on the stick, you must look at the 6 meter calculation and shift the decimal point one place to the left. By rounding off the new number at the decimal point, you have the half volume for a cylinder 6/10 of a meter long. A main advantage of the metric system is the ability to move the decimal when multiplying or dividing by 10, and it works for any portion of a meter from 1/10 to 9/10. Add these decimal calculations to the half volumes already obtained for an 11-meter log, and you get the volume of an 11.6 meter log. Now let's talk about your pace. On log booms, you've been measuring with a 6-foot stick, but now you must learn to measure with a 2-meter stick. Can you tell how many meters there are in your step? More to the point, can you tell how many steps are in a meter? A good way to get used to how many steps there are in a meter is by walking a tape distance. It may sound too simple, but learn to meter your step. Try 3 steps for 2 meters, or maybe 4 steps, whatever fits the length of your pace. Now, what do you do about deductions? In order to deduct for defects like this, work it out on your scaling stick. It's the best way to get an idea of how big a cubic meter is. And just how big is a cubic meter? Compared to the cubic foot, which you are now familiar with, the cubic meter is greater than 35 times the size. With this in mind, half volumes are marked on the stick in cubic decimeters. The decimeter is 1/10 of a meter, and a cubic decimeter is 1/1000th of a cubic meter. This may seem a little unclear, so let's look at it this way. The volume of a cubic decimeter is equal to the volume of a 1-liter carton of milk, or a 1-liter can of oil, or a round piece of wood 10 centimeters in length and 11.2 centimeters in diameter. Volumes will generally be computed to the nearest cubic decimeter. What about different shapes of logs? If the log is cylindrical and only slightly smaller at one end, as shown here, calculating the volume is simple. But logs aren't always shaped like that, and they can come in a wide variety of shapes and sizes. One example is butt flare. Here you must reduce the actual measure of the butt end, otherwise an incorrect volume is calculated. This reduction is made by projecting the line of normal taper through to the end of the log, and measure only that part of the log end within the line of taper. Secondly, there is the fact that the larger the difference between the butt end and top end diameter, the greater the chance that the calculated volume will differ from the actual volume. In an extreme case, if a log was conical, the true volume would equal 1/3 of the length times the sum of the areas of each end, whereas Smolian's formula calculates 1/2 of the length times the sum of the areas of each end. Smolian's formula calculates a true volume for logs which are cylindrical. Log shapes may vary from a truncated bullet, in which case the formula calculates a true volume, to a truncated cone, in which case the formula calculates too large a volume. Unfortunately, it is difficult to see these differences in shapes of logs. Overestimation of volume can be avoided by measuring the log as 2 logs. By measuring an intermediate diameter at point A and calculating the log volume as the sum of the volumes of each part, a truer volume is obtained, regardless of the shape of the log. Such an intermediate measure should be taken if the large end diameter exceeds the small end by 30%. In the case of deduction for rot, you must measure the affected area at the end, determine the length affected, calculate the volume of the rot, and deduct it from the volume of the log. With a little practice and experience, you will be able to estimate for these deductions in meters the same as you do now in feet. At first, you will probably want to convert your numbers to the metric system. This will only slow you down more. Try instead to think in metric. Here's a suggestion you might try to help you think in metric. Practice visual estimating by comparing something of a known size with something unknown. Take this loader, for example. If the wheel is 1.2 meters in diameter, what is the diameter of the log? If you estimated 0.4 meters, you're correct. How about this logging truck? If the overall length of the weigh scale is 18 meters, how long is the load? 14 meters is the correct answer. Here's another example. The cradles of this bunk are 6.5 meters apart. How long are the logs? Another comparison you should try is the average man, who is about 1.8 meters tall. Using the man for comparison, try to estimate the height of this stack of logs, or the diameter of this log. If you estimated 4.5 meters for the stack of logs, you're getting much better. Now, let's try something more difficult, like this conch rot. The knot is 2 meters from the end of the log. Rot is showing only at one end, so how many meters of the log are affected? Conch knots are usually a sign of rot for 2 to 3 meters above the knot and 3 to 4 meters below the knot. Since there are no conch knots below, it is safe to say that 6 meters of the log are affected. The volume of this 6-meter affected area is then calculated and deducted from the total volume of the log. Finally, there's the new tally sheet. It hasn't changed much at all. The log length and radius are recorded as before for each species and type scaled. Only now you record the log length in decimeters, which you enter as a 3-digit number, and the log radius in centimeters, which you enter as a 2-digit number. You should also note that one white column and the 2 green columns to the right of it represent a single log. For example, in column 60, line 3, 044 represents a log 4.4 meters in length. 09 represents a top radius of 9 centimeters, and 11 represents a butt radius of 11 centimeters. Now that you can see some of the pitfalls, here are some tips on how to avoid them. Coast scalers should practice measuring with the new 2-meter stick and adjust the length of their pace to fit this new measure. Deductions will be easier to calculate if you remember the decimal shift we spoke about. With the metric system, you can multiply or divide any number by 10 or multiple of 10 simply by shifting the decimal point. Once you have a good understanding of the calculations that can be made with the new scale stick, you should be able to figure tenths of volumes as easily as you can figure out whole volumes. Practice in visually estimating the size of unknown objects against known objects will also speed your estimating of the size of a meter. Lastly, watch out for that old trap that others around you are not changing. It's not that hard to learn the metric system, and you'll be showing leadership in accepting the new way. Once you've mastered it, you'll have a practical new skill that will prove valuable in many other parts of your life. So come on, you're on your way to becoming leaders in the world of metric.